Hello dear students, in this video we'll have a recap of all the concepts that we have studied in time series analysis. Now this time series, it is from unit 6, the remaining half part, and the weightage for this part, it is 5 marks. Now first we will see what is time series. A time series, it is a sequentially recorded numerical data points for a given variable which is arranged in successive order and that is used to track variation. So say for example, if we have the data for temperature for every hour, it is a time series data. Here these data points are recorded at successive times or successive periods. Now say for example, the temperature, it can be recorded for every hour or every day, or it say for example sales data, it can be recorded for every month or every quarter or every year, like that. So those data points are recorded at successive times or successive periods and they provide useful information for analysis or forecast. So this is an example of the power used in units over a period of time. So this is a time series data. Now we will see the use of time series analysis. It helps in analyzing how a given asset or security changes over time. So we can analyze the share price using this time series analysis. The share price are quoted over a period of time. So based on this time series data, we can see the trend in the share price. So that is one use. And then these series also help to see how a business or economic variable change over time. So it also helps in seeing how a business variable like sales, profit, or economic variable like inflation, GDP, all these change over time. Then we have, it gives insight on how changes associated with the chosen data points compared to the changes in other variables over the same period of time. So this analysis is also used for comparison. And then next we have, it helps in forecasting. Now we have different types of data analysis. The first one is time series data. In this time series data, the data of the variable is collected at distinct time intervals for a specified period of time. So here in time series data, the data of one variable, it is collected at different time intervals for a specified period of time. That is called time series data. And then we have cross-sectional data, when the data for one or more variables is collected at the same point of time. So if at the same point of time, the data for more than one variables, if it is collected, then it is called cross-sectional data. Next we have what is called the pool data. It is a combination of time series data and cross-sectional data. Next we have forecasting methods. It is classified into qualitative and quantitative methods. In quantitative method, we can use this method of forecasting only when the past information about the variable is available. Now say for example temperature, we can forecast temperature using this quantitative method of forecasting because we have past information about temperature. Again, when the information and data of the variable can be quantified. So we should be able to quantify the data of the variable. And then again, this can be used only when we can assume that the pattern of the past will continue in the future. Now say for example share price, usually we use quantitative method of forecasting share price because we assume that the past will continue in the future. If the share price is increasing, then it will still increase in the future. And next we have, the variable has a cause and effect relationship with one or more other variables. Now say for example the share price and price of gold, it is related. So like that, if there is a cause and effect relationship between one or more variables, then we can use quantitative method. The next method is qualitative method. This qualitative method of forecasting, it is based on the judgment of few experts and analytical opinion which is used to develop forecast. And this qualitative method, it can be used when information on the variable, it cannot be quantified, or historic information is not available and it is not applicable. In that case, we can use qualitative method of forecasting. Next, we have time series analysis. In this time series analysis, we have two types. One is univariate time series analysis and the other one is multivariate time series analysis. In univariate, we use only the data set of one variable, a time series in which data of only one variable is varying over time. It is called univariate time series or data set. Now say for example, if we want to collect data for inflation alone, here we can use univariate time series analysis. Here when a time series is a collection of data for multiple variables and how they are varying over time, it is called multivariate time series or data set. When analysis is carried out on the data for multiple variables and the two to see how they are varying over time, then we have to use multivariate time series or data set. Say for example, we can analyze the time series data of consumer price index, wholesale price index, then index for industrial production, all these over a period of time. Then such an analysis is called multivariate time series analysis and the data set is called multivariate data set. Now moving on to the components of time series. As far as the time series is concerned, that is the patterns and behavior of the data in time series, it is based on 4 components. So these are the 4 components. The first one is secular trend component. It is also known as trend series. Now this component, it is the smooth, regular and long-term variations of the series which is observed over a long period of time. Now if we see that the time series data, there may be fluctuations during a short period of time, but over a period of time we can see that the value of the variable increases or it may decrease. So that is called secular trend component. Say for example, consumer price index, it may show an increasing trend. Next we have seasonal component. When a time series captures the periodic variability in the data, capturing the regular pattern of variability within 1 year periods, then it is called seasonal component. Now if we see the sale of ice creams, then we can see that in every year the sale is high in summer and it is low in winter. So that component which is captured using the time series data is called the seasonal component. The main causes of this component may be climate change, seasons, customs and habits which people follow at different times. And then next we have cyclical component. Here a time series data, it shows an oscillatory movement where the period of oscillation is more than 1 year, where one complete period is called a cycle. Sometimes the time series data, it shows a cyclical variation. Here we have the time and here we have the data. It may show a cyclical variation where the period of oscillation is more than 1 year. Then that component is called cyclical component. And next we have the irregular component. These kinds of fluctuations, they are unaccountable, unpredictable and caused by unforeseen circumstances like natural calamities. It can be floods or labor strike. Such random fluctuations are caused by short-term, unanticipated and non-recurring factors that affect the time series. The best example for irregular component is the sales in online business because of the pandemic. So that we can consider an irregular component. So these are the various components of time series. Now we have trend analysis by fitting a linear trend line. So among all these components, we are trying to study the secular trend component. So this component we can measure using these methods. The first one is graphical method, where we plot a graph and draw the points and see how the variations occur. The next one is semi-averages method. Here we will divide the entire data into two halves. We take the average of first half and the average of next half, draw a line joining those 2 points and see the trend. That is semi-average method. The third one is moving averages method, and the fourth one is method of least squares. So these two methods we are going to study in detail. The first one is trend analysis by moving average method. This method is used to draw a smooth curve for the time series data. So here this moving average method establishes a trend line by eliminating cyclical, seasonal and random variations which is present in the time series. So that is the use of moving average method. Now this method we are familiar. We have studied the 3-period moving average and the 4-period moving average. In 3-period moving average, we find the 3-period moving total and then we divide that by 3 to find the 3-period moving average. And in 4-period moving average, we find the 4-period moving average and then the 4-period centered average. Now let us see some questions based on this method. These questions I have taken from Arihan's sample paper booklet. Similar question was asked in the sample paper for 2 marks. The production of a cement by a firm in the years 1 to 9 is given below. So for the years from 1 to 9, the production in ton of cement is given here. So this is the data which is given here. We are asked to calculate the 3-yearly moving average. Now let us draw a table like this. So we have year and then production in tons, and the data which is given in the question is written here. Then we have the next column which is 3-year moving total, and then we have 3-year moving average. So in this 3-year moving total, we have to add the first 3 years data and write it in the middle. You have to add these 3. 4 plus 5 plus 5, 14. Write it here. And then for the next 3-year moving total, we have to leave the first year and add the next 3 years data. So 5 plus 5 plus 6, 16. Like that we have to proceed. Then 5 plus 6 plus 7, 18. Then 6 plus 7 plus 8, 21. Then 7 plus 8 plus 9, 24. Then 8 plus 9 plus 8, 25. And the last one is 9 plus 8 plus 10. It is 27. So we don't have any values. That is the 3-year moving total for the first year and the last year. Next we have to calculate 3-year moving average. 3-year moving average is calculated by dividing this by 3. This is nothing but average of these 3. So it is, we already found the total. So the average is the total divided by 3. So here we have 14 by 3. It is 4.67. And then the next 3-year moving average is the average of these 3 values. We already found the total. So this divided by 3 will give the 3-year moving average. 5.33. Next 18 by 3, 6. Next 21 by 3, 7. Then 24 by 3, 8. Next we have 25 by 3, 8.33. And then 27 by 3, 9. So these are the trend values for these years. For the year 2, 3 up to etc. 8, these are the trend values. So when we have huge fluctuations, when we plot these points on the graph, on the other hand, if we plot these points, we will be able to get some trend. So that is the use of finding this 3-year moving average. So finding 3-year moving total carries 1 mark and 3-year moving average carries 1 mark. And now we have a question for 4 yearly moving average. From the following data, compute 4 yearly moving averages and determine the trend values. Also find the short-term fluctuations. So for various years from 2006 to 2015, the values are given. We need to find the 4 yearly moving averages. Now this question was asked, similar question was asked in the sample paper for 3 marks. Now let us draw a table like this. We have year and the values which are given in the question are written here. We need to have the columns with 4-year moving total, 4-year moving average and 4-year centered average. Here they have asked to find the short-term fluctuations. The short-term fluctuations are nothing but it is these values minus the trend values, that is short-term fluctuations. So first let us find the trend values. Here 4-year moving total is the sum of these 4 and we have to write in between these two. So 50 plus 36.5 plus 43 plus 44.5, it is 174, and then we have to leave the first year and add the remaining 4 years values and write it in between 2008 and 2009. So here when we add all these we get 162.9, and then next we have to leave these 2 years and then add 43, 44.5, 38.9 and 38.1. It is 164.5. Then we have to add 44.5, 38.9, 38.1 and 32.6. It is 154.1. Next 38.9, 38.1, 32.6 and 41.7. All these add up to 151.3. Next we have to add these 4 values until we reach the last year's value. It is 153.5, and then we have to add the last 4 values. When we add, we get it as 149.2. Now we have found 4-year moving total. When we divide each of these total by 4, we will get 4-year moving average. 174 by 4, 43.5, 162.9 by 4, 40.725, 164.5 by 4, 41.125, 154.1 by 4, 38.525, 151.3 by 4, 37.825, 153.5 by 4, 38.375, 149.2 is 37.3. Now since we do not get the trend value for the corresponding year, we get in between years, we have to find 4-year centered average. The 4-year centered average is average of these two, that is 43.5 plus 40.725 upon 2. So the average of these two, it is 42.1125. Then the average of these two, 40.725 plus 41.125 by 2, 40.925. Now the average of these two should be written in between so that we are getting the trend value for the year 2008. We will not get the trend value for the first 2 years. Then we will get the trend value for the remaining year, and again we will not get the values for the last 2 years. Then the average of these two, it is 39.825. Then the average of these two, 38.175. Then the average of 37.825 and 38.375. It is 38.1. Then the average of these two. It is 37.8375. So finding Fourier moving total carries 1.5 marks and Fourier centered average carries 1.5 marks. Here there is one additional question which is given. We have to find the short term fluctuations. So these are the trend values. The short term fluctuations, it is given by y minus yt. So we will not have the values for these 2 years. So for the year 2008, the short term fluctuation is 43 minus 42.1125. It is 0.8875. Then for the year 2009, it is 44.5 minus 40.925. It is 3.575. Then we have 38.9 minus 39.825. It is negative 0.925. Then we have 38.1 minus 38.175. It is negative 0.075. Next we have 32.6 minus 38.1. It is negative 5.5. Then we have 41.7 minus 37.8375. It is 3.8625. So these are the short-term fluctuations. Now moving on to computation of straight line trend by using the method of least square. So here if we see in 3-year moving average or 4-year moving average or 5-year moving average, we will not get a straight line trend which will fit the given set of observations. Whereas the method of least square, it is a technique for finding the equation which best fits a given set of observations. Here the sum of squares of deviations of the actual and computed values is least, and it also eliminates personal bias. Now some person may think of calculating 3 years moving average, some may think of 4 years moving average. So like that, in this method, it eliminates the personal bias. Now if we are given n number of observations and we are required to fit a straight line to these data, now we are familiar with the equation of line given by y is equal to a plus bx. So here y is the actual value, x is the time, and a and b are real numbers. So using this relation, let us try to find a and b, and we can find the equation of the trend line. And now we have estimation of constants a and b. Just now saw we can find a trend line which best fits the given set of observations as y is equal to a plus bx. Now how we can find this a and b? We can find the value of a and b using the normal equations. The normal equations are given by summation y is equal to na plus b summation x, and summation xy is equal to a summation x plus b summation x square. Now these two equations, they are called the normal equations. And now we have to have one important thing. It is we have to have summation x as 0. Here x is the time that we are taking. So say for example, if the time is given as 2003, 2004, 2005 and the various values of y is given. Say 10, 12, 8, like that the values are given. Now we have to shift the origin. If we take x as 2003, 2004, 2005, then we will not be able to find the values of a and b. Here we have to shift the origin and find x as xi minus 2004. If we do this, here for 2003, value of x will be minus 1, For 2004 it is 0. For 2005 it is 1. So that we get summation x as 0. So the first step is we have to shift the origin so that we get summation x is equal to 0. If we have summation x as 0, then from the first normal equation, we will get a as summation y by n. So 1 implies summation y is equal to na plus 0. From this we get a as summation y by n. Now we can find summation y, and n is the number of observations. Now we can find a. So that is the first way in which we can find a. Now if we put summation x as 0 in the second equation, we will be able to find b. So 2 implies summation xy equal to 0 plus b summation x square. This implies b is equal to summation xy upon summation x square. So we can find the values of a and b using this relation. The first step is we have to shift the origin, and then we can find summation y, summation xy and summation x square. By substituting all these values, we can find a and b and the trend line. Now here is a question. All these questions I have taken from Arihan's sample paper booklet. Under this method of least squares, we have two types of problems. Here the number of observation, the number of years is odd, or the number of years may be even. Here we can see that the number of years is odd. So this is the first type. Similar question was asked in the sample paper for 3 marks. Apply the method of least squares to obtain the trend values from the following data. So here we have year and the sales in lakh tons. The values are given. We should also predict the sales for the year 2013. Now let us draw a table like this. So here we have year, first column, then sales. This year is given by xi, sales is given by y. Now we have to shift the origin. If we have odd number of years, then the year in the middle, it can be taken as the origin. So we have x is equal to xi minus 2008. And then we have xy and x square. So here for 2006, the value of this capital X will be 2006 minus 2008, negative 2. Then for 2007, it is negative 1, 2008 0, 2009 1, 2010 it is 2. So that we have summation x as 0. Now let us find xy. Xy is this y into this x. So it is 100 into minus 2, minus 200, 120 into minus 1, minus 120, then 0, then 140 into 1, then 80 into 2. Now here we have summation xy. So here when we add all these, we get, here we have minus 320, then plus 300. So it is negative 20. Next we have x square. X square is square of these values. So minus 2 the whole square is 4, minus 1 the whole square is 1, 0, 1 and 4. So here summation x square is equal to 10. And this is summation y. Summation y, it is equal to 550. Now the equation of trend line is given by yt is equal to a plus bx, where a equal to summation y by n. So here summation y is 550 and n is 5. So 550 by 5 it is 110 and b is summation xy by summation x square. So summation xy is negative 20 and summation x square is 10. Minus 20 by 10 it is minus 2. Therefore, the trend line is yt equal to 110 minus 2x. So this is the trend line. We are also asked to calculate the trend values. So let us have another column for finding the trend values. So it is 110 minus 2x. Here we have to substitute each of the value of x and find the trend value. So here it is 110 minus 2 into minus 2. So it is plus 4. 110 plus 4 is 114. Then 110 into minus 2 into minus 1. So it is plus 2, which is 112. Then 110 minus 0. Then 110 minus 2 and 110 minus 4. So these are the trend values for various years. And then we were also asked to find the estimated sales for the year 2013. So for 2013, we have to find x. X we have taken as year minus 2008. So for 2013, x is 2013 minus 2008, which is 5. Therefore, estimated sales for 2013, yt will be, here in place of x we have to put 5 and find the value. It is 110 minus 2 into 5, which is 110 minus 10. So it is 100 lakh tons. The question it is given, the unit is lakh tons. So the estimated sales for 2013 is 100 lakh tons. Now drawing this table carries 1 mark. Then finding the trend line carries 1 mark. And finding the estimated sales carries 1 mark. Now moving on to the next type. In this type, here the number of years is even. So this is the second type. The time series given below shows the number of TVs sold by a company since 2003. So for various years, the TV sold in 1000 is given. So here we can see that the number of years is 10. Find the linear equation that describes the trend in the number of TVs sold. Also estimate the sale of TV in 2014. So we just have to find the equation of the trend line and estimate the sale of TV in 2014. So let us draw a table like this. Whatever is given in the question is written here. So let us take year as xi, TV sold as y. Then we have capital X as. Here when the number of years is even, we have to take the average of the 2 years in the middle. 2007.5. So we have to take x as xi minus 2007.5 upon 0.5, or we can take it as into 2. So if we see 2003 minus 2007.5 upon 0.5, it will be minus 4.5 into 2, or it is negative 9. So here we will have the x value as negative 9. Similarly, for the next year 2004 minus 2007, 7.5, it is 3.5 into 2 is negative 7. Then for 2005 we will have negative 5, 2006 negative 3, 2007 negative 1, 2008 will be plus 1, 2008 minus 2007.5 will be 0.5, 0.5 by 0.5 is 1. For 2009 it is 3, 2010 it is 5, 2011 it is 7, and for 12 it is 9. Again we will get summation x as 0. So here we have summation x as 0. Only then in the normal equation we can substitute summation x as 0 and find a and b. Then we have xy and then we have x square. Now let us find xy. 42 into minus 9 minus 378, 50 into minus 7 minus 350, 61 into minus 5 minus 305, 72 into minus 3 minus 225, then 92 into minus 1 minus 92, 111 into 1 111, 120 into 3 360, 127 into 5 635, 140 into 7 980, 138 into 9 1242. Now let us find summation xy. Now when we add all these we get minus 1350, and when we add all these we get 3328. So summation xy is 1978. And now we can find x square. X square, first we have minus 9 the whole square, 81 minus 7 the whole square, 49 minus 5 the whole square, 25 minus 3 the whole square, 9 minus 1 the whole square, 1, 1, 9, 25, 49 and 81. When we add all these, we get summation x square as 330. And now summation y we have to find. Summation y is, when we add all these we get 956. The equation of trend line is y is equal to a plus bx, where a equal to summation y by n. So it is 956 by 10, which is 95.6, and b is summation xy upon summation x square. So it is 1978 upon 330. Now this when we divide, we get it as approximately equal to 5.994. So we have found a and b. Therefore, the required equation is yt is equal to 95.6 plus 5.994x. And now we are asked to estimate the sales for the year 2014. For the year 2014, we have x as, we will have 2014 minus 2007.5 upon 0.5. So it is 2014 minus 2007.5 upon 0.5. It is 6.5 into 2. So it is 13. So we have yt as 95.6 plus 5.994 into 13. Estimated sales for 2014 is, so this when we simplify, we get it as 173.52, and here the sales is given in rupees 1000, so it is rupees 173.52 thousand. So these are the various concepts and various problems that we have in time series analysis. I hope this video was useful for you. Thank you for watching.